In our last video, we had seen the various problems related to cantilever beam subjected to only point load, and another one problem, cantilever beam subjected to uniformly distributed load. In this video, we will see the combination of point load and UDL whenever it is acting on the cantilever beam, how this shear force and bending moment diagram will be drawn. So you can see here, it is a cantilever beam. Here one point load of 10 Newton is there, another one point load of 20 Newton is there, and here another one UDL is there, which is extended up to 2 meter and having a value of 10 Newton per meter. So first what we will do, as we are doing in our previous videos also, so first we will name the salient points. Let this is A, B, C, D, E. Now we will go for drawing the shear force and bending moment diagram of this beam. So for that purpose, what we will do, first we will take the cross section or the section AB of the beam. So for that purpose, we will take one hypothetical cross section XX at a distance of x from K. So let us draw that one here. This is XX and this is the portion right side of the beam, 10 Newton, and this distance is x. So at x, SF at x is equal to how much? This is 10 Newton, and this if this force will act, this is the right side of the beam. This right side of the beam will go in the downward direction. I have told in my previous video, RUL. If right side is going upward, then that will be negative. Here right side is going downward, so this shear force will be positive. So that is plus 10 Newton. Bending moment at x will be, bending moment value is force into distance. Here force is 10 Newton and distance is x. So 10 into x, as this is when this load will act, there is a tendency that this will bend in this direction. So in this case, the sign is negative, minus 10x Newton meter. So at A, in this case of A, x will be 0. In the case of B, x will be 2. So at A, x is equal to 0. At B, x is equal to 2. So SF at A, as you can see in the SFX formula, there is no x is there. That means it is independent of x. So that's why both in the case of A and both in the case of B, that will be the same value, that is plus 10 Newton. Here also SFB is equal to plus 10 Newton. Then BM at A, here x is equal to 0, so minus 10 into x, that is minus 10 into 0, that is 0 Newton meter. Similarly, BM at B, that is minus 10 into x in this case of B is 2, so minus 10 into 2, that is minus 20 Newton meter. Now let us draw that one here. This is the line for shear force and this is the line for bending moment. Shear force at A is 10 Newton, at B is also 10 Newton. So the line will be like this. And bending moment at A is 0, at B is minus 20. So this is 0, this is minus 20 Newton meter. Now the question is that whether from here to here this line will be a straight line or it will be a curve, because we don't know about the intermediate points. So from here to here it will be a straight line or it will be a curve. Simply it will be a curve because here the equation is that BMX equal to 10 into x to the power 1 is there. So as I had told in the previous video is also y equal to mx plus c, that is the formula for a straight line. Whenever x to the power 1 is there, then the curve will be a straight line. So here it will be a straight line. 0 and this is minus 20. Now let us go to the BC. Whenever we are going for the BC, let us take a cross section XX at a distance of x from B. Draw here. For cross section BC, draw here. This is x-axis and this is the portion right side of the x-axis. This is 10 Newton. This is 20 Newton. This distance is 2 meter and this distance is x. So at x, SF at x is equal to how much? This is plus 10, this is plus 20. So plus 10 plus 20, that is plus 30 Newton. Bending moment at x is equal to minus 10 into 2 plus x minus 20 into x minus 10 into 2 plus x minus 20 into x. So minus 20 minus 10x minus 20x, this will be minus 30x minus 20 Newton meter. Similarly at B and at C, in case of B x is equal to 0, in case of C x is equal to 2. So at B x is equal to 0, at C x is equal to 2. Put the value of x here. So SF at B, simply it is independent of x, so 30 Newton. SF at C, this is 30 Newton. BM at B is x equal to 0, so minus 30 into 0 minus 20, so minus 30 into 0 minus 20, that is minus 20 Newton meter. In this case x equal to 2, so minus 30 into 2 minus 20. Bending moment at C is equal to minus 30 into 2 minus 20, that is minus 80 Newton meter. Now draw this one. Here shear force equal to 30. Previous case it was 10. Now it will go up to 30 here, 30 Newton. At C also it is 30. So the line will be like this, 30 Newton. Bending moment at B is minus 20. At C is minus 80. Again it will be a straight line because x to the power 1 is there. So simply extend this one up to like this, minus 80 Newton meter. So now we have drawn the shear force and bending moment diagram up to this. Now we will see the cross section CD. So for cross section CD, take x-axis in between C and D at a distance of x from C. Now draw that one here. This is x-axis 10 Newton, 20 Newton, and this is the UDL 2 Newton per meter. This distance is x, this is 2, and this distance is 2 meter. Now at x, SF at x will be how much? Plus 10 plus 20 plus 2 into x. Plus 10 plus 20 plus 2 into x, that is 30 plus 2x. Bending moment at x will be how much? 10 into 2 plus 2, 4 plus x. So minus 10 into 4 plus x minus 20 into 2 plus x minus, this is 2 into x into where it will act? It will act at x by 2. So 2 into x into x by 2. Now simplify this one. Minus 40 minus 10x minus 40 minus 20x. 2 gets cancelled, minus x square. So this will be minus 40 minus 40 80 minus first one is minus x square minus 30x minus 80 Newton meter. Now at C, in case of C x equal to 0, in case of D x equal to 2, at C x equal to 0, at D x equal to 2. So SF at C will be how much? As x equal to 0, so 2 into 0 0, so this will be 30 Newton. SF at D will be how much? 30 into 2 into 2 4, so that will be 30, sorry, 2 into, this is 10 10x. This load is 10 Newton meter, na? 10x, this is 10 to 5, so minus 5 x square, this will be minus 5x square. Actually here this one is this one, this is 10 actually, 10 into x by 2, 10 into x by 2. So here is also minus 10, sorry, plus 10 plus 20 into plus 10 into x. So 30 Newton, here it is 30 into 30 plus 10 into x, x is 2, so 10 into 2, 50 Newton. Bending moment at C is minus 5 into 2 rho square, 2 square is 4, so minus 20 minus 30 into 2, 60. Sorry, here this is x is 0, so as x is 0, 0, 0, minus 80 Newton meter. Here x is 2, so 2 square 4 minus 5 into 4 minus 20, 30 into 2, 60. Bending moment at D is minus 20 minus 60 and this is minus 8, that is minus 160 Newton. Now draw this one. Shear force at C is 30, shear force at D is 50. This is 50 Newton, so the line will be like this. And bending moment at C is minus 80, bending moment at D is minus 160. This is minus 160 Newton meter. And this line will be a chord line because of this x square. So the bending moment diagram will be this. Next, let us go to section D. Let us go to section D. So for D, take a cross section XX in between D and E, and now draw the XX. This is X, B, this is C, 10 Newton per meter. This is 20 Newton and this is 10 Newton. This distance is 2, this is 2, this is 2. At XX, SF at X will be 10 plus 20 plus 10 into 2. 10 plus 20 plus 10 into 2, that is 20, that is 50 Newton. DM at X will be 10 into 2 plus 2 plus x, that is 10 into 6 plus x, 20 into 2 plus 2 plus x, that is minus, these are minus 20 into 4 plus x, and this one is 10 into 2 into this load value will be 10 into 2 load value, okay, whenever it will be converted into point load, and where it will act at the center, the center means 2 by 2 1, so into 1 plus x. This is the bending moment value. So this will be minus 60 minus 10x minus 80 minus 20x minus 20 minus 20x. So 60, 80, 40. That is minus 60, 80, 180 minus 180 minus 30x. So at d x is equal to 0, at e x equal to 1. At d x equal to 0, at e x equal to 1. So SF at d, as it is independent of x, so directly 50 Newton. SF at e, that is also 50 Newton. Bm at d, that is x value is 0, so minus 180 minus 30 into 0, so minus 180 minus 30 into 0, that is minus 180 Newton meter. And Bm at E is minus 180 minus 30 into 1, that is minus 210 Newton. Now draw this one. Here it is 50, here is also it is 50. So this is the shear force diagram, bending moment diagram. Here it is minus 180 and here it is minus 210. Now this is the shear force diagram and this is the bending moment diagram. Thank you.